Good afternoon, good evening, or good morning. This is the man of Leet here with a problem to figure out for you. So it's called binary tree level order traversal. So we're just going to get down to it, okay? Let's read the problem, let's solve it. Given the root of a binary tree, return the level order traversal of its nodes values from left to right level by level. Now, I want you to think. Level order traversal, what does that mean exactly? So we're starting at the root, right? Then we are going to the root's children, right? So as you can see right here in the example, 3 is the first level, 9, 20 is the second level, 15, 7 is the third level. So based on this approach, right, let's pretend I had like the 9 had a child of, I don't know, 10 and 12. Then the last level would say 10, 12, 15, 7. So this should be ringing bells in your head saying this problem requires a BFS approach. Anytime that you see a level order traversal problem with binary trees or any kind of graph problem really, I want you to think binary. I mean breadth first search. If you don't know what that is, you might need to do a little bit more reading, but for now, I'll tell you the gist. BFS, you always want to start with a queue, all right? And I'll explain how it works here. So we have a queue. If you don't know what that is, I can explain that as well. So queue, it is a first in, first out data structure. And why we use it is because we want to list out all of the children of the node we are currently at before traversing to the children of those nodes that we just captured. So that is the purpose of this queue. Now, you might be asking yourself, how do I use it for a binary tree problem? I'll tell you how. With the magics of Python, uh, you can also do this in other languages, but in Python it is significantly easier. And if I were you, I actually used to be a Java person myself, so I would advise you to switch to Python if you want to continue to solve more Leetcode problems. It is a strong language. You can very versatile. There's a lot of great qualities about Python. It's very easy to understand as well. So as soon as you can, if you can, shift to Python. If you're comfortable in your current language, go ahead. So what this queue is going to do, right? We're going to start, we're always going to be given a root node. This is our root node, right? Root node has children. So we'll call this one left child, and then this one will be the right child. I'll put an I after it so we don't get confused. So in the queue, we just put in this root node, right? Because the root node will have references to the children, left and right child. So our first level, what is it going to be? Our queue is just going to have this node in it. That's it, the root node. Then when we come down here, what's the queue going to have? It's going to have the left node, it's going to have the right node. Because we're going to take this node out and then add these two. Let me take those out. So what does this look like to you? This kind of looks like the levels, right? So in each level, it's basically we're just copying the queue into a 2D list that we are going to that we're going to return out. So what would the answer be here, right? Our result would be we have the root node, that's a level, and then we have this second level, which is the left and the right node, and that would be our answer. So this will continuously happen. This is basically how you solve the problem, and if we're comfortable, we can go ahead and move on to the code. So the code, for time's sake, I'm going to paste it and walk through it. So first things first, if the root doesn't exist, right, we just want to return out nothing, right? After that, we can create our queue. In Python, you can use a list and then just pop from position 0. There you can also use a deck. Whichever one you want to use here doesn't matter. Same methodology, same principle as what I just explained. So we append the root to our queue, and we create this results array, which is going to contain all the levels that we have. And we're basically just going to iterate through this queue. And this is a very like, if you're not familiar, like this is, you're going to always be basically iterating through the queue while it exists. And here, this is another way of saying while the length of the queue is greater than 0. We were just going basically until it's empty. And after that, what we want to do actually is we don't want to pop anything just yet. We want to take the length of the queue. Why? Because of this principle right here where I'm saying the queue at each level represents the level itself. We just want to copy that into our results array. So right here, this is our results array. I didn't make that clear here. This is our results array. Let's go back. And if you haven't noticed, they want just the values of those nodes. They don't want the nodes themselves. So we come down into here, right? We just want to iterate through the range of the queue length. And the reason we can do this is because our queue here is just a list. So we could just go by index. And now you might be asking yourself, why do I have Q0 here? That's because that is a code I had before. And before that, it was actually QI. Now, this doesn't work because we're not popping anything out of our queue. The reason why this is complicated is because after we iterate through this certain range, right, how do we kind of cut off the old nodes that we've already seen? Well, for that, since we're already going through this queue length, this range already, we can just pop from the 0th index and basically take out every single node that we're going to explore. So we take the node off, then we say we have this level here. It's going to represent the level, right? Then we just append the value to that node, to that level, and then after that, what do? We just want to check if this node has a left child or a right child, and then append that node to our queue again. And then at the very end of exploring that level, because we're only going up until a certain length, we're not going to explore the children of the nodes that we just discovered, right? We just append the level, and then that should be it until the queue is finished executing, like while we're going through the entire thing and it empties out. This will just contain all the results we want. And as you can see, it does work here. So we have that 3, we have the 9, the 20, the 15, the 17. I mean, 7. All right, let's just run it again. We're good. And let's hit submit. And we're good. Success all around the board. And I hope you guys learned something. And this was the Man of Leet. Thank you so much for watching.